Happy New Year, everyone! It's 2026, which can be factored into 2 and 1013, making the number a semi-prime, one with only two factors other than 1 and itself. And that's basically the end of everything interesting about the number, at least compared to how epic 2025 was, being a square, the sum of the first 9 natural numbers squared, and the sum of the first 9 cubes of the natural numbers. But I'm sure we can find some redeeming property of 2026, like maybe it's the sum of some consecutive integers? Okay, we can work with this. So obviously it's the sum of one consecutive integer itself, but with 2 it fails, and with 3 it fails. Luckily, it works with 4 consecutive integers, and we get our first fun fact that 505 plus 506 plus 507 plus 508 equals 2026. I wonder if there's a quicker way to do this. Let's suppose we take k consecutive integers, starting with n. Then their sum is going to be n plus n+1 plus n+2, all the way up to n plus k minus 1. Rearranging some terms, we get kn plus 1 plus 2 up to k minus 1, which we can then further simplify to kn plus k times k minus 1 over 2. So now we have an expression, we can try setting it equal to 2026 and seeing what happens. Well, it's actually not too bad. We can just multiply 3 by 2 to get rid of our fraction, and then expand and regroup the terms to get a quadratic in k, which, remember, is the number of consecutive integers. But this isn't your typical quadratic, because we have a second unknown, n, the starting number, in there. Luckily, we can use our insane mathematical knowledge in the form of the fundamental theorem of algebra to say that this polynomial has 2 solutions, a and b, which means we know that the above can be written as k minus a times k minus b equals 0 for some suitable a and b. And this is the really nice part, because we know that k itself has to be an integer, so a and b both have to be integers as well. Comparing terms, we get that AB is minus 4052, which can be split up in 3 different ways. Then we can just systematically try our values of A and B and get some answers. When doing this, you'll get 2 values of k for each starting number n, but one of them will always be negative, so you can discard it, because it doesn't make sense to consider minus 4052 consecutive integers. Mathing the math, we get the following 4 solutions. 2026 is the sum of 1 consecutive integer, starting and, funnily enough, ending with 2026. It's a sum of 4 consecutive integers, starting with 505. It's a sum of 1013 consecutive integers, starting with minus 504. And it's a sum of 4052 consecutive integers, starting with minus 2025. What's interesting to note is that the big ones are the small ones plus 0. Except the 0 is in the form of adding n-1 through minus n-1. So really, the one example we found manually of 4 integers was the only interesting one. Okay, I give up. There has to be something interesting about this number. And to find out what, we turn to the OEIS, the Online Encyclopedia of Integer Sequences, which has some fun facts for us. 2026 is a semi-prime between a square number and a prime number. It's 1/5 of the 24th multiple of 5 that has a digit sum of 5, which I know is a very significant result. It's the sum of 7 cubes in exactly 9 ways, but what those 9 ways are left as an exercise to you, the viewer. And finally, on a slightly ominous note, 2026 will have 3 Friday the 13th. So good luck this year, and thanks for watching.